Welcome to the third segment of our celebration today. First, we had a worksite tour at 10 a.m. France time, and then we had the formal ceremony with the statements. We are now going to our press conference, and so I would like to give just a few explanations before those of you here or those of you joining us remotely will offer questions to Dr. Bigot. First of all, for those journalists who are joining us here, if you would like to speak directly to the microphone that is at the front, the only thing that we ask you is, because we respect COVID-19, please don't touch the microphone. If you just speak close to it, we will be able to hear you. So journalists who want to do that, you're welcome. In addition to the many journalists around the world that have been accredited to join us on our special platform for journalists, please send your questions whenever you like. And as many as we can, we will try to consolidate and to ask Dr. Bigot. Then in addition, if for some reason there are too many and we run longer than an hour, just send the questions in writing to any of the individuals who were named on the press release as contacts, and we will get back to you as soon as possible. First question, Dr. Bigot, is coming from Anita Von Mont, and I should ask, for those of you coming to the microphone or submitting questions, if you can tell me the name of your news organization, that would also be helpful. So, first question, what is meant with the announcement that in December 2025, first plasma shall be launched? What plasma will this be? Is it only created with normal hydrogen atoms or already self-heating plasma able to produce more energy than the reactor consumes?
The first plasma in 2025 indeed will be just with standard hydrogen to check that all the different pieces of the tokamak building, of the tokamak installation has been properly assembled. It will not produce energy. It's just the first step to check that everything has been according to expectation. After that, we will install the system to collect the energy. Okay, as you know, the helium nuclei as well as the neutron will escape from the plasma and be collected by the wall, and we need to install this system. Furthermore, we will install also some extra heating in order to be able to reach a temperature of 150 million degrees. And last but not the least, we need to recycle the fuel, and so we will have what we call a tritium plant. So it's still a long journey to go, but it is needed in order to secure the performance of this very complex, first-of-a-kind installation.
Thank you. Next question, actually asked by a number of journalists, is, can you describe, from a practical standpoint, how you have managed to accomplish so much progress during the COVID-19 pandemic? And can you give any specific illustrations, either from ITER countries or from the ITER organization, where you experienced and dealt with particular challenges?
Indeed, we are lucky enough to have ITER members spread over all the planet. So when we experience the COVID-19 hitting China, and we feel that it could come to Europe and France, we have decided to anticipate the COVID-19 impact, and we set up an organization with most of the teleworking. We also impose to all the workers on the ITER site to wear masks. We were fortunate again that we received early enough before the pandemic some gift from China and Korea in order that we could provide the mask to a worker on the work site. And last but not the least, we rely on the high motivation of all the ITER members. Each of them were fully aware that it is quite easy to stop a project like this. You just order, stop, and everybody stop. But to restart, it would be a nightmare. So it's why we have decided to have what we call a continuity plan, preserving the critical activities we could not stop including to receive some of the components which were already loaded, shipped, and going on the sea. So it's what I call the ITER miracle. Okay, we have been fortunate enough to be able to go on continuing the activities without any infection within the ITER community.
Thank you. And can you give any specific examples about specific challenges, technical challenges otherwise, that arose during the last, say, 6 months?
Many challenges. I would say every day we have challenges. When you see the size, for example, of the cryostat base, the lower cylinder, the upper cylinder, they have to be manufactured with a very high precision, and they have to be leak-proof. And to be frank with you, for example, we have checked that it was so, and there was one part which was not complying with the specification. And so we have to grind it again and to redo it. Is the price to pay for high quality. So based on this experience, we have been able now to have perfect product to be installed. Once they will be installed in the tokamak, we could not reduce them. We could not repair them. They have to be perfect before they come into the plasma, the tokamak installation for plasma. I could speak also of some others. For example, with the coils, as I explained, we need to a precision which is below millimeter between the surface of the coils and the surface of the casing. And it was not easy to get it, and so we have to work very hard, and I am pleased that we comply with this specification also.
Thank you. Could you repeat which nations are involved in the assembly of the project, and how are scientists from nations who currently experience acute tensions, like the US and China, or China and India, how are they working together, and have diplomatic issues slowed the project or risk derailing it? Thank you.
The ITER project is based on an agreement. It has been decided that the 7 ITER members will procure in-kind the component. The responsibility of its assembling and installation is the ITER organization. But we need to rely on the experience of the staff, of the engineers, of the workers, which are manufacturers of these components. So it's why we work as an integrated team under the responsibility and leadership of the ITER organization for the assembly. And we are very pleased to work with many companies coming from all over the world, including, for example, China is responsible for the positioning of the cryostat, and many other countries are participating.
Thank you. There's a question from Alexander Teleshev, a special reporter with the TASS newswire in the Russian Federation. He says there's been a lot of progress technically with regard to plasma confinement, fuel injection, and other processes that directly control the efficiency of the thermonuclear reaction and can improve ITER success chances. Is there a cutoff for such proposals to be implemented? And if there is, how and when do you decide how the first plasma will be achieved?
As you know, this project is a research project. You never stop the research progress. The scientists are always very creative, imaginative, gaining experience, moving forward to a better understanding and control and mastering the physical phenomena. So from my point of view, the ITER project will go on, and in parallel, many progress will be done worldwide in many labs as well as other installations. The big difference is they have not the proper size in order to have what we call a burning plasma, a self-sustained plasma. And this is why we are ready to integrate all this progress in our project in such a way that we could demonstrate their pertinence in order to be able to provide fusion energy in the best condition when it will be ready to start.
Thank you. A question related to cost. what do you consider the cost in euros or dollars of the total ITER project? And are there also returns on investment in terms of economic benefit even before we receive full fusion power?
Clearly, this question of cost is a very often asked question. And it is very difficult to answer. Why? Because, as I explained a few minutes ago, a larger part of the construction is depending on the in-kind contribution of the several members. And everybody could understand that the workforce price in California is not exactly the same as in Mumbai. Okay, each country has its own economics capacity and procedures. So the only things I could do, I have a matrix. The matrix is the cost for the European Union. As you know, the cost for European Union is fully controlled by the European Parliament. And I know that the European Union is contributing 45% of the construction phase. And so it's quite easy, by comparison with the cost, if it would have been fully constructed and built and assembled in Europe, what would be the cost? And when we compare to the cost dedicated only to ITER, not speaking the, I would say, running cost of the fusion for energy and other project fusion of energy has in charge, the cost is of the order of 20 billion euro value 2015 when I came in.
Thank you. We see often in the news reports on big achievements by smaller projects, some things like Tokamak Energy or like the MIT project. How does ITER view those projects, and are they working together with you for the future of fusion?
I see all these smallest projects, as you name it, with a very positive attitude. From my point of view, it's already a success for ITER to have stimulated this new project in such a way, demonstrate that more and more people feel that hydrogen fusion could be a real option for the future. Second, as I have said, we have to decide, the design of this machine. We decided by 2007. We know we have to build it. We could not change the design every day. So we will go until the end with our design, integrating progress if it is possible, but some progress will not be. So it's good that other devices, much smaller, which from my point of view could not achieve the goal of ITER, which is a sustained plasma, a burning plasma, producing 10 times heat, the heat we are injecting in the plasma. I don't believe they could achieve that, but so they are complementary of our action, and we are very pleased to work with them as often as it is possible. We are not in a competition, we are really, from my point of view, complementary.
Thank you. A somewhat related question. Do you expect an actual fusion power plant to be a scaled-up ITER reactor, or is it some kind of hybrid that you would expect with other technologies that may emerge, such as spherical tokamaks?
Our plan is, once we have completed our mission to demonstrate the feasibility, viability, and economic competitiveness of hydrogen fusion, that we will replicate this type of devices, which looks the most promising, with a scaling up, maybe twice as large as this one, to be able to provide power to the grid. And but as you said, there is alternate devices, tokamak, spherical, as you said, for example, which could be good also. I don't want to eliminate any of them. Just let's have a fair competition and see what is the best, and maybe we could enrich each other.
Thank you. We see quite often by climate change experts statements that we need to go to 100% renewables. Also, that we need to move away from centralized production of energy and more toward decentralized. How do you view that idea?
You know, I am a physicist, I am a chemist indeed, and I trust, okay, the physical phenomena. When we are a population of nearly 8 billion, okay, soon 10 billion, with a very large urbanization, when we have highly concentrated means of production, you need continuity and massive production of power. And renewable energy, by the way, all come from the sun, okay, radiation, okay, on Earth, on the sun energy flux. They have two limitations. The largest limitation from my point of view is their, okay, diffuseness. Okay, you collect only a limited flux of energy by square meter, and we could not change that. Sun has been working this way for 5 billion of years and will go on 5 billion more. So it is an input data, flux of solar on Earth. And so if you want to power 10 billion of inhabitants, mainly living in cities, 80% of the world population is now living in cities. If we want to have large, okay, production means, continuity and massive production is needed. Whatever the progress on storage, I do believe that the order of energy we need, whatever the saving, will not work. I don't say that, okay, renewable energy has not to be considered. They have to be considered as much as we can. And very large project has been made indeed in the very few decades. But from my point of view, it is impossible to expect that we have 100% of your renewable energies. Okay, maybe just a small house, maybe, but not at the size of humankind. So it's why we need a complement source of energy which will fit and okay, adjust with the weak point of renewable energies, which is massive and continuity. And you could complement, which means that if you have a need, you could increase your power production. If you don't, it's a very nice solar day, as it is today in Provence. We have a lot of wind. Okay, you could shut down the fusion power and start it again immediately when the clouds will come in. So it's very good that we have these two complementary technologies.
Thank you. About 5 years ago, there was a lot of skepticism about the possibility of ITER succeeding. How did you turn the project around?
It's not myself we have turned the project around. It is the ITER members. You know, when I was requested to consider to take this responsibility, and indeed I was not at all prepared to do that, I say, sorry, I am not a miracle man, but just I know the recipe in order to be successful. And so if the ITER members agree to follow the rules I propose to them for the governance of the project, will mean first, clear decision process. I feel sorry to say, I have requested that the ITER Organization Director General is fully empowered to take decision. Clearly, it means to analyze the pros and cons of any decision, to consult, to have large discussion. But when comes the time for decision, please take decision. Second, we have 7 ITER members, 7 domestic agencies. Before, we were working more in parallel, in some silo. I say it could not work. We have to work in the most integrated way, as one ITER team. And last but not least, we have to be realistic. Okay, the schedule to deliver this project initially was much too enthusiastic. Okay, we come in, okay, I consult a lot of industry, I consult a lot of experts, and we come with a thorough review, and I present to the ITER members my conclusion. My conclusion was not enthusiastic for them. Before, it was felt that ITER first plasma will be 2020, and the full fusion power was 2025. And I explained it was physically impossible. They have to accept, and it was very challenging to have a schedule which will be first plasma by 2025 and full fusion power through what we call a stage approach with a sequence of complement installation of component and some experiment for the scientists by 2035. So I don't know if it will succeed. We work hard, and I am pleased to say, since 2015, we are on track. We have been able to deliver according to our plan and our schedule with high quality. It's not my responsibility. It is the responsibility of the ITER members and all the staff. In my role, I am just, as I said, a facilitator. I don't prevent the other to work well.
Thank you. A question from Nate Gronewald at E&D News. After first plasma is achieved and experimented with in 2025, we see that it will be followed by a quote, shutdown phase. What is the purpose of that and the next steps?
First plasma, as I explained, the main component of the tokamak, the vacuum vessel, leak-proof, huge, toroidal vessel, more than 1,500 cubic meter. The 18 vertical coils, what we call the toroidal coils, the 6 vertical ones, the central solenoid, all the cryogenic plants, all the different systems will be installed. And if it works, it will be a major landmark. But we know in order to complete our mission, we need some more equipment. We don't want to put this equipment immediately, because if, for example, we face a leak and we have to make some repair, we will have to disassemble what we have assembled, without any benefit. So the next step will be nearly during 2 years to install what we call the first wall, the panel which will collect the energy coming from the neutrons when they will be hit. And it's why, after this installation with robots, you have to understand that each of these parts is weighing more than 4.5 tons, and only the robots could install them, and there is 440 of these tiles. We will be able to offer to the scientists the possibility to start, with a plasma which will deliver some energy. But still, we will need some extra heating. And that's why, after 18 months, fully dedicated to the physics experiment, we will take over, the machine and, install the extra heating. And second, campaign of experiment will go before we finally install the recycling plants for the fuels.
Thank you. With the additional challenges from the coronavirus outbreak, will it be necessary to extend the ITER construction schedule and/or ask members for extra resources? This is from Dan Cleary at Science Magazine.
Clearly, the pandemic has impacted the schedule, initial schedule. You know that, for example, in some countries, for example, Italy, we have the workshop which has been stopped for nearly 2 months. Also, there is quite a large disruption in the supply chain, also limitation in the capacity of some of our expert engineers coming from a remote country to France. But I see an extraordinary motivation to try to recover this impact. I have been requested by the ITER Council to assess the impact of this COVID-19 shutdown, and by the end of September, I will report on this assessment, and I could say you more. You listen as me by all the higher dignitaries of the ITER members. They are willing to have first plasma as soon as possible. So we will try our best in order to keep with our commitment. But again, we have to be modest and humble. If it is physically impossible, whatever the price we will pay, we will have to accept. It will be a delay, of a few months. I don't believe it will be a major step back, because maybe we could recover after that.
We have a question here. I don't have a name, but it is, I assume, from China. could you describe in particular the role of China as an ITER member, and how do you think China is doing as a partner?
China is a major partner. They joined the ITER project indeed, in 2003, as you know, and they learn very rapidly, on fusion. It's very impressive for me. They procure a lot of equipment. They are very reactive. So for me, just a very good example of the strong commitment of the ITER members. I am pleased to see that many of my Chinese colleagues demonstrate high skill and motivation, and so I wish that they stay as such up to the very end. So thanks to China, as I will say, thanks to all the 6 other members.
We have a historical question. Could you tell us how it was that ITER was chosen to be placed in Cadarache in France rather than somewhere else?
It's a difficult question, even if it is public. Indeed, fusion has always been something important for France. You have to remember that, for example, the jet has been under the leadership of French engineers, as well as the beginning of the ITER project, when it started in San Diego in the US, Naka in Japan, and Garching in Germany, in Europe. And so there were a strong motivation of the scientists to have ITER in Europe, and if possible, ITER nearby the CA Center, Atomic Energy Commission, where you have a superconducting magnet, tokamak, which was working since the 1980s. So the French scientists pushed for that. Second, France and Europe was considered by the 7 ITER members as a well-balanced position. All of them trust that France could be serious about nuclear safety, engineering capacity, welcoming of the different countries. And so it was a negotiation and discussion, and France has been chosen, and I am pleased and proud that this has been decided. And as you know, France is doing everything they can in order to accommodate. And last but not the least, and I guess my ITER colleague will say, Provence is not the worst place to be in the world to make science. I will not comment more, but I do believe that worldwide it is well known that Provence is a very pleasant place to be.
The last question that I have, unless we get more, is we read that, we understand that fusion power is primarily expected to produce electricity, and that electricity currently represents only 20% of global energy consumption. When you look toward the future, how do you see the rest of the 80% being made up, or can you use fusion for other applications?
As you see, fusion first produces heat, and so we could imagine that we will use the heat directly. Why not? It's happened in many countries where you have a network for heat transportation, and you could heat the cities and so. Second, I do believe that the electricity will take over many other energy consumption. Now, for example, many cars are just running with gasoline. We see more and more cars running with electricity, with power. We do believe it is a future for transportation. I see very recently a plane with only electricity power. So from my point of view, if we want to have a clean energy world, environmentally respectful, we will use more and more electricity.
Thank you. That concludes, unless we have anyone here. I think many of you have interviews already lined up with Dr. Bigot this afternoon. for those of you who have not already interviewed. So this brings our entire press conference as well as the overall 3 phases of our Start of Assembly celebration to a close. Thank you to all of you here who have joined us. Thank you to all of you who have joined us from around the world. We invite you to continue to follow our progress as we work to make fusion energy the energy of the future. Thank you.
Thanks a lot. Thank you, Liban.